So this is the setup solution for problem number 60 in the free body diagrams. So I've got a box sitting on a ceiling being pressed or pushed by a force at a 55-degree angle, and the box is accelerating to the right at 6 meters per second. Here's a reference line, and there's a body that represents the box, and then it's got a force pushing on it at a 55-degree angle. Opposing the force is friction from what the problem says. Friction opposes motion, so since the motion goes to the right, friction goes to the left. And the box has mass. Since the box has mass, it's going to have weight. So the weight of the box I'm going to write as mg. It also has a normal force. Typically we think of the normal force as going upwards, but actually the normal force is the reaction force of the ceiling. So the box is being pushed into the ceiling is pushing back on the box. Remember, our forces are all forces that act on the box itself. So in this case, the normal force is going to go down. The box is also accelerating to the right at 6 meters per second, so that means it's going to have a net force going to the right. So that's my MA net. Remember that your net force, or MA net, never touches the body. This is the answer when you add up all the forces. You get MA net as the answer. And then I'm going to have my coordinate system so I can sum up the forces. I'm going to choose parallel to the acceleration and perpendicular to the acceleration. Now that I have this, I need to go look at the forces and see which forces match my coordinate system. So friction is parallel to x, or parallel to the net acceleration, so that works. mg and the normal force are both perpendicular to the net acceleration, so I'll leave those alone. But the applied force F isn't parallel or perpendicular, so I need to break that up into a triangle with components that are parallel and perpendicular. So I'll draw a right triangle around the angle. I'll start off with the horizontal component being parallel to the net force, that's F cosine 55, and a component perpendicular to the net force, that's going to be F sine 55. So at this point, I no longer need the force when I'm summing up the components. So I'll start with sum of the forces in the x direction, and that's accelerating, so that's going to equal to MA net. If it's not accelerating, it's equal to 0, but this one is because it's 6 meters per second, so that's MA net. And that's going to equal all the forces going the same direction as MA net minus all the forces going the opposite direction. Remember that pluses and minuses are direction indicators. Pluses match our direction, minus is the opposite direction. So F cosine 55 is the same. It's positive minus friction because friction goes the opposite direction. Then I can do a little bit of math to isolate the frictional force, and from there I can plug in some numbers. I could go on and solve, but I'm going to stop right here and go to the next part of summing up the forces in the y direction. So I'll sum up the forces in the y direction. In the y direction, it's not accelerating. It's perpendicular to the acceleration. So when I sum up the forces in the y direction, it's equal to 0. Don't forget, it's a math sentence, so you have to show all your steps. The sigma, the f, and which direction you're in this case the subscript y. And then it's got to equal a net acceleration, which for here is 0. And that's going to say all the forces in one direction minus all the forces in the other direction. So here, F sine is going to the right, and then minus eta and minus mg because they're going to the left. Rearrange it, so I get eta is equal to F sine 55 minus mg. Plug in my numbers, and I get F is equal to mu times eta. So when I'm solving this in the next couple steps, these are the formulas that I'm going to use, the ones in blue that are nice and bright. I'll also use friction. The nice thing about friction is I've got to find the coefficient of friction, and I have friction described above, eta described in the bottom equation, and I can plug those values in, the numbers that I calculate for F and eta in the friction equation.